Today we're going to talk about 5.3 and 5.4. 5.3 has to do with kites and trapezoids, and 5.4 has to do with mid-segments. 5.3, you should have the 5.3, 5.4 notes handout in front of you. The upper left box will be this slide, which is a kite. I know that the writing is kind of small. I just wanted to have it in front of you. It says here a kite is a quadrilateral with two sets of consecutive sides congruent. We saw a kite earlier this year. The non-vertex angles of a kite are congruent. Notice the vertex angles are the ones that fall in between our congruent sides. So the vertex angles are up here and down here. And the non-vertex angles will be congruent. One of the best ways that we can prove that those are congruent is if I was to draw a diagonal, then based on what we learned last chapter, I've got a shared side, and I have this triangle over here congruent to this triangle by side, side, side. CPCTC would tell me that those two angles are congruent. So the non-vertex angles are congruent. That will be important as we move through the notes. Next one, the diagonals of a kite are perpendicular to each other, and actually the diagonals connecting, let's make sure that we've got this marked and this marked and this marked and this marked. Now when we take a look here, the diagonal connecting the vertex angles of the kite is the perpendicular bisector of the other diagonal. So I drew that one on the perpendicular bisector of the other diagonal. So you can see this is a vertex angle, this is a vertex angle. This diagonal here is the perpendicular bisector of the other one. And since this is a right angle here, and since this up here we've got sides, this one is bisected, perpendicular bisector, cuts into two congruent halves and forms a right angle. Let's see, we're looking at the next slide. The vertex angles of a kite are bisected by their diagonal. Bisected by their diagonal. So we've got a bunch of congruent triangles when we throw together all of this stuff. So again, that's congruent to that for the kite. That's congruent to that for the kite. Now we have side, 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 which by CPCTC means these are going to be congruent, which means that the vertex angles are bisected. Okay, so those are the major things about our kites. The vertex angles bisect. So we could add this into this picture right here. We get those ones. We get those ones. And actually, if you take a look at this one here, we would get this guy right here and this guy right here. So there's a lot going on with our vertex angles when we draw our diagonals. Next deal, a trapezoid is a quadrilateral with one pair of opposite sides parallel. So we know we've got that parallel to that. Since we have parallel lines, if we think about parallel lines and alternate interior angles, we also had the consecutive angles between the bases are supplementary. Supplementary means we're going to add up to 180 degrees, of course. We know that these two, because we have this transversal idea here, remember the same side interior angles were supplementary. That came back from a couple of chapters ago. These ones over here would also be supplementary. So whenever you know one angle, you know the opposite base. So again, the bases are always going to be congruent, so you can figure out some missing angles. If we're talking about an isosceles trapezoid, isosceles trapezoids means the non-parallel sides are going to be congruent. The base angles of an isosceles trapezoid are congruent. Notice there are two sets of base angles. We have a set of base angles down here. We also have a set of base angles up here. And if you think about it even further from what we just said, these two are supplementary, these two are congruent. These two are supplementary, these two are congruent. So if we knew one angle of this guy, for example, if this is 60, this has to be 60. If these are supplementary, this has to be 120, and this has to be 120. So in an isosceles trapezoid, please note it must be isosceles for this to be the case. regular old trapezoid, those angles are not necessarily going to be the same thing. Diagonals of an isosceles trapezoid are congruent. Again, congruent. That's an R. Congruent. Again, I've got isosceles, must be marked. I have a trapezoid, one pair of parallel sides. So if I name this A, B, C, D, AC is congruent to BD. Based on the triangles that are formed, there's a bunch of things that we can tell about this based on our side angle side and things like that. But definitely B to D is going to be equal to A to C. So the diagonals of an isosceles. Now only isosceles trapezoid, not a regular trapezoid. We're going to do a few problems together. We'll skip over a couple on the slides here, but you have these. If you flip to the next page of your handout, if they're telling us that the perimeter is 116, I know this is 28, this is 28, this is x. This is x for my kite. All I have to do is add up 2x plus 2 28s must be about 56 equals 116. Solving, I get, let's move that 56 over. 2x equals 60 if my math is correct. X equals 30. I get 30. Based on what we know about kites, we can solve some simple problems. Next one has to do with, it looks like a trapezoid, and this looks like an isosceles trapezoid. It's important that you recognize that that was marked up. If they didn't give us the isosceles, there's not a lot we could do. The base angles of an isosceles trapezoid will be congruent. Therefore, pretty quickly we can figure out that y has to be 56 degrees. If y is 56 degrees and this is a trapezoid, again we've got our same side interior supplementary, parallel, parallel. So 180 minus 56 must be about 124 degrees. Hopefully that isn't too difficult for you to see. Moving on, looks here like we have actually an isosceles trapezoid on the bottom. We have a kite on the top. We said that the non-vertex angles of a kite are going to be congruent. So if that's 137, this is 137. If this single tick is 137, this single tick is 137. If this is a base angle of an isosceles trapezoid and it has to be supplementary with its other base angle, its same side interior supplementary angle, then we can do 180 minus 137, and y must be 43 degrees. Only thing left to solve for is going to be our x. Notice I've got a quadrilateral. From what we learned yesterday, the sum of the interior angles of a quadrilateral is 360. So I've got a 137, a 137, and a 22. Together, I think 137 and 137 must be about 274. 274 and another 22 must be about 296. And if I'm left over from 360, then I'm talking about 64 degrees for x. And we should be in good shape there as well. Let's see, next guy looks like a kite to me. A couple things that we know. First of all, this is congruent to this, so it looks like I should put trips on there. And I know this is a right angle. We know that right out of the chute. If this is a right angle and this is 41 degrees, then I probably know that this up here is going to be 49 degrees. Notice these two triangles right here have a shared side, which means this is 41 degrees. We know that because the vertex angles are bisected, which means y is also 49 degrees. I've got a right angle here. I've got a 78 and a right angle. This must have to be 12 degrees. Notice I got a triangle with a 78, a 90, and what we're missing. So this is going to be 12 degrees. Lots of congruent triangles in our kites because of side, side, side. That does it for our trapezoid and kite problems. Let's move ourselves on. Let's go down the line and talk about, we're up to 5.4 now, so we're on 5.4. Mid-segment connects two midpoints of a triangle. So if we're connecting a midpoint to a midpoint, that means this is congruent to this, and this is congruent to this. This is the most important thing we've got going on with mid-segments. A mid-segment is half its opposite side and parallel to its opposite sides. Parallel. How many L's in parallel? A whole bunch. So I know that this is going to be like that, and that's going to be like that. If this is x units, this is 2x units. So anytime you know one of these two, knowing that that's a mid-segment, I know for a fact that it's going to be half, and I know that it is parallel. Since it's parallel lines, notice I've made myself a little trapezoid here too, haven't I? So we can probably utilize those skills as well. Three segments of a triangle divided into congruent triangles. Notice this would be congruent to this. This would be congruent to this. This would be congruent to this. Now take a look at this funky one. This distance here is parallel to this distance here. If this is twice as much as this, then this has to be a single ticker. And notice this distance over here, a double ticker and a double ticker. Well, again, this is parallel to that because it's the mid-segment that is opposite of it. So it's going to be half the entire distance, which means, well, this is half of the entire distance. We get a double ticker there. Same thing down here. I get those two triple tickers. Half of those together leaves me a triple ticker. Well, notice side, side, side tells me I got 1, 2, 3, 4 congruent triangles whenever I'm connecting up my mid-segments. The mid-segment of a trapezoid is blank to the bases, is parallel to the bases, eh? Parallel. How many A's in the word parallel? Is parallel to the bases and equal to the average of the bases. How do we average two numbers? Remember, the bases are the parallel sides, and we're saying that this is going to be parallel as well. So a mid-segment of a trapezoid cuts that and that, cuts that and that. Notice, they did not tell us if this was an isosceles trapezoid, so I cannot assume that all four of those are exactly the same. But it gets to be kind of fun when you do get to do that. I got parallel lines, so I got this congruent to this, and I got this congruent to this because of what we know about corresponding angles. Back to our initial, I got bases of 8 and 14. The average, how do we average two numbers? 8 plus 14 divided by 2. That must be about 22 divided by 2. 22 divided by 2 is 11. 11. Notice there's a difference of 6 there, which means we got to be 3 up and 3 back. A couple different ways we can do that problem, but in this case it's 11. Take a look at the next problem. They did not tell us, but we are going to go with the idea that these are mid-segments, which means this is the case. If I've got mid-segments, remember that and that are parallel. If this is 54 and this is 37, I believe 54 and 37 must be 91, which makes this little one down here 89. Please note, this angle C is an exterior angle. These are its remote interior. Those have to add up to it. 91 and 89 also form a linear pair. So I get 91. A bunch of different ways we can figure that out. I got parallel lines here. If this is 54, this has to be 54. If this is 89, this has to be 89. So we've got a bunch of different ways we can figure out what B is, 54, and what A is, 89. Hopefully this is going fairly smoothly for you. Let's go to the next one. Again, this is a mid-segment. We're going to call this a mid-segment, which means this is the same as this. So if this is 16, this is 16. Together, then Z must be 32. 32. This is X. This is 21. That's 21. That's 21. Whole side would be 42 if they asked us for it, but they didn't. And remember, this is the side that's parallel to its mid-segment right there, and the base will always be twice as much as the midsegment. Half of 14 is 7. Okay, look for midsegments whenever you can. Again, I got a midsegment of a trapezoid here. Let's mark it up. Should be pretty easy. I'll do number y for you. Number y must be 11. If this whole side is 13, z is half of 13. Grab your calculator, 6.5. And then lastly, 29 is the midsegment. Remember, it's an average. We can do this two ways. I could say the base plus the base divided by 2 equals the midsegment. This would be doing it algebraically. How do we clear out the fraction? How about we multiply both sides by 2? So I get x plus 41 equals 58. Subtract 41 from both sides. X equals, that must be 17 if I did my math correctly. Now, we also could have done, since this is fairly easy arithmetic, there's a distance of 12 from there to there. There's got to be a distance from 12 to from there to there. 29 minus 12 is 17. Algebraic method will come in handy if you have ugly numbers, or sometimes you might have to do it with just variables, which makes it a little bit more difficult. Just a couple problems left. Let's take a look at this guy right here. Let me see if I can make this one a little bit bigger for us so we can see what's going on. I know this one's real small on your sheet. It says the perimeter of the whole thing, PQR, is 132. It says that right there. Now, perimeter of XYZ. Before we start filling in a whole bunch of numbers and trying to calculate the perimeter up, let's think about the fact that XZ here is half of RQ, ZY is half of PQ, and XY is half of PR. If we're half of the side, half of the side, half of the side, then would you not agree with me that the perimeter has to be half of the perimeter? So 132 divided by 2 must be about root 66. I know that the perimeter of that is going to be root 66. It says here that RQ, that's this distance. RQ is 55. If RQ is 55, we're looking for ZX. RQ and ZX are parallel, and ZX have to be half. That's going to be 27.5. If I did my math correctly, it should be, oh no, it's not 27.5, is it? Is it 27.5 or 26.5? I can't read what's going on here. That's 55, half of 55. Somebody better check my math. Is it 27.5? Half of 50. Oh, I think I got it right. Okay, PQ. I'm looking for PQ, and they haven't given me any information. They gave me PZ. PZ is 20. Well, if PZ is 20, then this is 20, and this is 40. Hey, I got the whole perimeter of the big guy. 40 and 55 is 95. What's 132 minus 95? 132 minus 95 must leave me with 32 plus 5, or 37. 37. So if I've done my math correctly, I think I have it right. Last one we're going to take a look at. Explain how to find the width of the lake from A to B using a tape measure, but without using a boat or getting your feet wet, or flying a plane, or taking a picture from space, or I don't know what that would do for you. But why don't you push pause and see if you can figure out this one on your own, if somebody can run up and push pause before I tell you how to do it. So push pause. Okay, you're pushed pause. Okay, great. Okay, you're back. So either you decided not to push pause because I'm not here and you're not going to listen to me, or you can do something like this. Let's make this out here, and then let's take and make this out here. Now, what am I trying to find? I am trying to find the distance from here to here without getting my feet wet. So what am I going to do? I'm going to take and I'm going to get my tape measure out, and I'm going to measure the distance from here to here and calculate the midpoint, and measure the distance from here to here and calculate the midpoint. I can then construct the mid segment. which is not in the water, and go ahead and get my trusty tape measure out and measure that, because I'm not in the water, for the mid segment. Just got to make sure your triangle is big enough so your midpoints aren't in the water there in the lake. So now if this is going to be X units long, I know that not only is the mid segment parallel to it, but it's also twice as much. So whatever the mid segment is, we can go and double it, and now I know the distance of the lake. That would be one method of indirect measurement. Indirect measurement. All right, so that's basically the notes for 5.3 and 5.4. You are now able to work on Chapter 5, Day 2, which will be passed out momentarily. So for the rest of the time, you should be finishing up your Chapter 5, Day 1, and working on your Chapter 5, Day 2. We will talk about both of those things on Monday when I return, and I look forward to it. Have a wonderful day.